Imagine starting with a fade-in from absolute darkness, slowly revealing a shimmering tapestry of stars, spiral galaxies with their graceful arms, ellipticals softly glowing, and irregulars with their whimsical shapes. This visual sequence, accompanied by an immersive soundtrack, not only delights the eyes but also arouses curiosity about the mysteries these vast stellar assemblages conceal. Following the opening sequence, the narrative begins with a warm and inviting voice, highlighting the importance of galaxies not only as fundamental components of the universe but also as entities that carry the secrets of cosmic evolution itself. In the vast ocean of the universe, galaxies are like islands teeming with stars, each telling a story of birth, life, and eventually, a peaceful decline. Here, the objective is clear. Today, we will embark on the epic journey of galaxies, exploring how they are born, live, and die on the cosmic stage. From the first lights echoing after the Big Bang to the silent fading into the fabric of space-time, each galaxy has a saga to tell. This introduction promises viewers a deep and engaging exploration of the life cycle of galaxies, setting the stage for a narrative rich in information and visual beauty. Before delving into the cosmic odyssey that is the life cycle of galaxies, it's crucial to establish a solid understanding of what galaxies are and how stars, their fundamental components, are born. This segment of the video serves as a vital introduction to the basic concepts necessary to fully appreciate the complexity and beauty of stellar evolution. We begin by demystifying what galaxies are: vast cities of stars, gas, and dust, bound together by gravity. Each galaxy is a microcosm with millions, if not billions, of stars, each potentially orbited by planets, forming solar systems. Galaxies are primarily classified into three types: spirals, with their graceful arms filled with young stars; ellipticals, huge clusters of old stars with little star formation; and irregulars, which defy these categories with their unique shapes and active star-forming processes. The process of star birth is fundamental to understanding galactic evolution. Within vast clouds of gas and dust, known as nebulae, gravity begins to pull material together, condensing it into increasingly dense regions. As these regions collapse under their own gravity, the center becomes so hot and dense that hydrogen atoms begin to fuse, creating helium and releasing energy in the process, the birth of a star. This moment marks not only the beginning of a star's life but also acts as a driving force for galactic evolution, as newly formed stars will influence the dynamics and chemistry of their host galaxy. The story begins in the chaos that followed the Big Bang, where matter began to coalesce under the force of gravity. Giant clouds of hydrogen and helium gas, along with dark matter, formed the foundations of the first galaxies. This dark matter, invisible but detectable by its gravitational influence, acted as a kind of skeleton upon which normal matter accumulated. In dense regions, gas began to collapse under its own gravity, forming the first stars and, consequently, the first galaxies. This period, known as the era of reionization, marks the moment when the universe emerged from its primordial darkness and was lit up by the lights of the first stars. After their formation, galaxies began to evolve in complex ways. Initially, many were small, fragmented, and tumultuous, often colliding and merging with each other in a universe still in its infancy. These mergers were crucial for the growth of galaxies, allowing them to accumulate mass and, over billions of years, evolve into the larger, more stable structures we observe today. During this period of intense activity, the rate of star formation reached its peak, known as the stellar formation peak. As galaxies mature, the rate of new star formation begins to decline. Spiral galaxies, like the Milky Way, establish distinct arms, rich in gas and dust, where star formation continues but at a more moderate pace. Elliptical galaxies, on the other hand, exhibit little new star formation and are dominated by older stars. This stage of maturity is not the end of galactic evolution. Gravitational interactions with other galaxies can lead to mergers, fueling new episodes of star formation or completely altering their structure. The cosmic dance between galaxies is a grand spectacle of attraction and fusion, a process that not only shapes their structures but also influences their evolution. This segment will explore how gravitational interactions between galaxies trigger dramatic events and transformations, highlighting the importance of these interactions in the galactic life cycle. Galactic mergers. When galaxies come close to each other, their gravitational forces begin to interact, pulling them into a spiral of approach. This process can lead to a merger, where two or more galaxies combine to form a single larger entity. Galactic mergers are large-scale cosmic events that can trigger bursts of star formation as gas and dust compress under intense gravitational forces. Additionally, mergers can result in the formation of supermassive black holes at the center of the merged galaxies, altering the central dynamics and distribution of stars and gas. Effects of mergers. Mergers are not just destructive events, they are fundamental to the evolution of galaxies. Through these interactions, galaxies can experience renewal and rejuvenation as fresh material is integrated, generating new generations of stars. However, the process can also lead to a rapid consumption of gas, eventually depleting the material needed for new star formation and driving the galaxy into a more passive and aged state. In some cases, mergers result in the creation of giant elliptical galaxies, dominated by old stars and with little or no active star formation. Influence of gravitational tides. Even without a complete merger, the mere close passage of one galaxy can have significant effects on another, through gravitational tidal forces. These interactions can distort the shapes of galaxies, pulling long tails of stars and gas out of them and, in some cases, triggering new regions of star formation. This phenomenon, known as tidal interaction, highlights the complexity of the forces at play in the universe and the ability of galaxies to influence each other in profound ways. As we progress in the cosmic narrative, we reach the final stages of the galactic life cycle, a period marked by stellar transformation and the eventual galactic decline. This segment focuses on the end of stars' lives and how it influences the gradual death of a galaxy. Death of stars asterisk. The fate of a star is inherently linked to its mass. Smaller stars, like our Sun, eventually deplete their nuclear fuel and transform into white dwarfs, while massive stars culminate their lives in cataclysmic explosions known as supernovae. This latter phenomenon not only disperses heavy elements into the interstellar medium, enriching future generations of stars and planets with the building blocks of life, but can also leave behind black holes or neutron stars, objects of unimaginable density. The galaxy's end asterisk. Over time, galaxies face a progressive depletion of molecular gas, the primary ingredient for new star formation. This decline in star formation leads galaxies into a phase called redness, where older stars predominate, emitting primarily red light. Eventually, some galaxies may collide and merge, forming larger but less star-forming galaxies. Others may simply cool down and fade away slowly. their stars drifting apart as the dark matter that holds them together weakens under the universe's continuous expansion. Cosmological evolution ***. This process of galactic aging is not just an end but part of large-scale cosmological evolution. As galaxies age and transform, they continue to contribute to the cosmic cycle of matter and energy, from enriching the interstellar medium with heavy elements to eventually recycling matter into new cosmic structures. This endless cycle of birth, life, and death on a galactic scale is a testament to the evolutionary dynamics of the universe, offering insights into the past, present, and future of the cosmos. In this segment, we will explore specific case studies to illustrate how the life cycle of galaxies manifests in the observable universe. These concrete examples will help us visualize the complexities of galactic evolution, offering insights into the process from star formation to galactic interactions that shape the fate of galaxies. One of the most photogenic and studied galaxies, the Sombrero Galaxy, is notable for its prominent dust ring and a bright central bulge, evidence of a rich and complex structure. Located about 29 million light-years from Earth, this lenticular spiral galaxy provides a glimpse into how the components of a galaxy, such as stars, dust, and gas, interact to create a distinctive appearance. Its bright dust lane is a site of active star formation, while the central bulge harbors a population of older stars, demonstrating the stellar life cycle within a galaxy. The fate of our own galaxy, the Milky Way, and the Andromeda Galaxy is one of the most fascinating case studies in astronomy. It is predicted that these two giant spirals will collide in about 4 billion years, an event that will result in the merger of the two galaxies into one, possibly a large elliptical galaxy. This process offers an extraordinary insight into how galactic mergers are a key component in the evolution of galaxies, leading to new phases of star formation and drastically altering their structure and composition. Dwarf galaxies, such as the Magellanic Clouds, are smaller and less massive than galaxies like the Milky Way, but they play a crucial role in the study of galactic evolution. Often found as satellites of larger galaxies, they can be cannibalized or distorted by gravitational forces, providing fresh material for star formation in the host galaxy. Studying these dwarf galaxies helps scientists better understand the dynamics of galactic interactions and the process of growth and evolution of galaxies over time. As we explore the life cycle of galaxies, we touch not only on the fascinating narrative of their existence but also on broader implications for understanding the universe. This segment highlights the importance of studying galactic evolution in unraveling the mysteries of cosmology, dark matter, and the ultimate fate of the cosmos. Studying galaxies and their evolution is fundamental to understanding the structure and history of the universe. By observing galaxies in various stages of their life cycle, astronomers can construct a model of how the universe has expanded and evolved since the Big Bang. This includes understanding the distribution and nature of dark matter, an invisible component that constitutes most of the universe's mass and plays a crucial role in galaxy formation and evolution. The evolution of galaxies is also intricately linked to dark matter and dark energy, two of the greatest mysteries of modern physics. Dark matter helps explain how galaxies remain bound together despite the seemingly insufficient speed of visible matter to prevent their dispersal. On the other hand, dark energy, responsible for the acceleration of the universe's expansion, influences the long-term fate of galaxies. By studying galaxies and their dynamics, scientists hope to gain insights into the true nature of these enigmatic entities. Finally, galactic evolution offers clues about the ultimate fate of the universe. Depending on the properties of dark energy, the universe may continue to expand indefinitely, leading to a big freeze, where galaxies drift apart at ever-increasing speeds. Alternatively, a change in the nature of dark energy could eventually reverse the expansion, culminating in a big crunch, where the universe collapses back on itself. The study of galaxies is therefore essential for understanding not only where we came from but also where we are headed.